So we're going to start off with the bow work. Now, I want to give you guys a heads up on that homework assignment, which I just put up there. It is going to be hard, and it is going to take you a while. We're doing proofs, and proofs are difficult. They require a kind of different kind of thinking than you're used to. So it's really important that you take your time, not get frustrated. The earliest that's going to be due is Monday. Okay, so I'm not expecting you to do it tonight because we're going to be working through this. So my assumption is that we're going to be working on proofs today, tomorrow, and Monday. Yep. And then we'll do a review day on Tuesday, and then Wednesday we will take the Chapter 2 test. Summer. Yes. Sure. No, yeah. Yes, actually. If you, yesterday's assignment, if you did not finish it in class, it was homework, and I do expect it to get turned in today. For those of you who weren't here yesterday, clearly, turn it in tomorrow. Okay, so when we're looking at the bell work, so here we have this equation. 4 times x minus 7 equals 6. So the first step, and I want you to understand that what proofs are, is basically explaining to people why you did what you did. So it's important to be able to first show what you did. Now, some of you, this one's a little bit trickier because it has fractions. I say a little bit, but you guys should be able to do this. Some of you guys maybe even in your head. So even if you can do it in your head, and you're used to doing things like this in your head, I want you to fight that urge. Simply going, well, the answer is x equals 34 over 4 is insufficient. Because then, because we're doing proofs, because this is geometry, applied algebra, I'm going to ask why. Why did you do that? And there's some people who sit there and go, well, that's the right answer. And for me, at this point when we're talking about proofs, it's not that the right answer is unimportant, but how you got there is equally important. And being able to justify every step you did is equally important. So we have, I'm actually going to move that down just a little bit. It is. But we're going to get there in just a second, Fabian. Okay, so someone want to tell me what the first step that they did was? Distributive property. Right, so we're going to distribute. So we take that 4 and we multiply it by everything in there. And we get 4x minus 28 equals 6. Someone else, what was the second step? Taylor. Add 28 to both sides. And so we end up with 4x equals 34. Victoria, what'd you do next? Divide by 4. Anyone disagree with that? Anyone get something different? 34 over 4, 17 over 2, or 8.5. Any of those are acceptable answers. Those are the only acceptable answers. Did anyone get something different? If you did, do you know why? If not, please let me know. Okay, so that's step 1. So step 2 now is we have to justify that. Justify each step you take with the appropriate rule, property, etc. So what we're going to do is I'm going to make my little table here. So we've already done, half the work. So these are our steps over here, and then we need our justifications. This is step 1, 2, 3, and 4. So over here we're going to have 1, 2, 3, and 4. Now keep in mind that what we're doing here is, for step 1, we're asking how did we write down step 1? Fabian, you had said it earlier. What is it? Step 1. Why did we start off with 4 times x minus 7 equals 6? That's our given. That's what I told you to work on. So, step 2, we're asking how did we get from step 1 to step 2? Distributive property, exactly. So distributive property. And we know that because we got rid of those parentheses, right? We look at the distributive property. The distributive property says A, open parentheses, B plus or minus C, close parentheses, is equal to AB plus or minus AC. And that's what we have here. We took that 4 and we distributed it throughout the parentheses. So now, we're looking at how did we get from here to there? What did we do to get from step 2 to step 3, Bella? Of? That's right. Now keep in mind there are a lot of kind of mirror properties. There's properties of equality and properties of congruence. It's important to make sure you know which one you're dealing with. So this is called the addition property of equality. There are also properties of inequality. So there's the addition property of inequality. And finally, how do we get from step 3 to step 4? Okay, what was that? Division property of equality. And that should fundamentally be what your bell work looks like today. That is a 2-column proof. And I want you guys to get in the habit of doing the work on the left hand first and then justifying the steps. I think that will make it easier for you. Instead of trying to set it up step by step, all of you guys are fairly decent at algebra, so you should be able to go through and most of these problems just kind of knock them out on the algebra problems. You guys quiet down, please. Pretty much knock out the algebra problems. Now on the geometric proofs, that's what we're going to start today. It's going to be a little bit trickier, but I'm going to kind of show you how I would attack them. And if that makes sense to you, great. If not, then we can try and figure out a different way. So before we get going, are there any questions on bell work? Any questions on the assignment from yesterday? All right. Okay, I want you guys to all, in your book, turn to page 120, please. Jesse, is that arrow all the way down? Is that Victoria? Yes. Yes? Okay, so we've talked about vertical angles before. And we know that vertical angles are formed by two angles who are made up with opposite rays. So this is angle 1, that's made up with the black lines, angle 2, right there with the yellow lines. And so we know that we have that if we call this A, B, C, D, and E, we know that ray AB and ray AE are opposite. And we know that ray AC and AD are also opposite. And that's the definition we've been using for vertical angles. Two angles created by opposite rays. And so these are vertical angles. So what we're going to do when we first went over this, I said opposite rays are always congruent. Their measures are always equal. Hold on just a second, guys. So you guys are working on this. I know it's a little bit different, but you need to show that the measure of angle BAC is equal to the measure of angle DAE. Actually, that's exactly how I had it before. So you guys got about 3 minutes left. Okay, so you guys just had 5 minutes to come up with an explanation of why those two angles must be equal to each other. Anyone think they've got something? Taylor and Jesse. Okay, yes, and remember how I said you don't have to use angles or theorems or anything like that. I said why. Come up with a convincing argument. Be able to sit there and tell me why they have to be the same. Yeah, go ahead.
Because BAC and CAE are supplementary angles.
Okay, so hold on. So you're saying that BAC, right here, and what? CAE are supplementary.
Yes.
Okay.
And DAE and CAE are also supplementary.
Okay, so measure of BAC plus the measure of CAE equals 180. Measure of angle CAE plus the measure of angle DAE equals 180. Okay?
And they have to be the same measure because you have the same angle adding up to the same number of degrees with each of the angles.
Okay. Does that make sense to anybody? Does that make sense? If 4 plus x equals 8, and 4 plus y equals 8, then x and y have to be the same number. That makes sense, right?
Yeah.
And that's basically the argument that Jesse just made. And that actually, when we walk through the proof, is basically going to be how we're going to show that those two are the same. We know that this angle, so we're looking for relationships here. We know that this angle right here and this angle right here add up to what? They're opposite rays, so they have to add up to how many degrees? 180, right? Is everybody comfortable with that? Can everyone look at that and go, okay, I see that. Tim?
Yep.
You can't see anything because you're staring at your legs. We then have this angle right here and this angle right here add up to what, Tim? 180, right? So if I know, let me write these numbers. I'm going to put in a 3 and a 4 right there, okay? So I know that the angle 1 plus angle 3, their measures, equal 180, right? Is everybody comfortable with that? Yeah. And I know that the measure of angle 2 plus the measure of angle 3 equals 180. Does that make sense?
Yep.
So the measure of angle 1 equals the measure of angle 2. Same exact logic we use here to figure out that x and y are the same. Now notice, we don't actually have to do the math. We just know that they're the same. In this case, it's easy. X and y both equal 4. But over here, as Brittany was fond of showing, it doesn't matter whether they're here or here, those vertical angles are always going to be the same. Because my watch and my elbow are always going to form a vertical, are always going to form a linear pair, right? This angle right here and this angle right here. If I go down here, they still form a vertical pair. And so those vertical angles are always going to be equal to each other. So now let's look at the book and see how they do it. And what I want to show you is that they basically did it the same way. They start off, and I'm going to be doing a lot of flipping back and forth, so I apologize. I'll actually just erase this one. They start off by saying angle 1 and angle 3 are vertical angles. Okay? That's step 1. So go back here. Angle 1, they did it differently. We're going to go angle 1 and angle 2 are vertical angles. Actually, I'm going to switch the angles over here. I think it makes more sense. There we go. So if you're not here and you're watching this, we're basically looking at page 121 up at the top of the page, proving the vertical angle theorem. So 1 and 3 are vertical angles. So the second step they do, what we're doing is we're kind of listing everything that we know. So we look here and we go, okay, what do we know? What can we deduce from this picture? Well, we know that angle 1 and 2 are supplementary. Right? Because they form a linear pair. Everyone okay with that? Looking back at that picture? Going 1 and 2? Yep, those are supplementary angles. Sure are. And if 1 and 2 are supplementary angles, then we can also state that angle 2 and angle 3 are supplementary. I'll go back and I'll spell supplementary correctly. And that's for the same reason. So we start off by saying, okay, those are supplementary. What does that mean? Brenna, what's so special about supplementary angles?
That
They equal 180. So we're going to say the measure of angle 1 plus the measure of angle 2 equals 180. And the measure of angle 2 plus the measure of angle 3 equals 180. Right? So basically we just use the definition of supplementary angles to sit there and go, okay, well, if 1 and 2 are supplementary, then that means the measure of angle 1 and the measure of angle 2 equal 180. Does that make sense? I know this is boring. I know this is dry. I get it, but you really need to kind of buckle down and force yourself to focus through this. Yeah, because it's one of those things that learning it well the first time is going to be so much better than trying to learn it on the fly later on. Because this process of logical thinking, of breaking everything down to unbearably detailed steps and justifying each step is something we're going to be doing a lot this year. I just totally bit my tongue. Okay, so then we're going to look at number 4. And check this out. If A equals B and B equals C, then A equals C. Transitive property, good job. Both of these equal 180, so they must equal each other. Right? Remember we did that yesterday on the board? 4 times 3 equals 12 and 6 times 2 equals 12. Therefore, 4 times 3 equals 6 times 2. Same general idea here. It's not the same general idea, it's the same specific idea. And then what I'm going to do is I'm going to subtract the measure of angle 2 from both sides. And so I'm going to get 5, which is going to give me the measure of angle 1 equals the measure of angle 3. Now this next step may seem super stupid to you, but it's important. We then write 6, angle 1 is congruent to angle 3. And what we're really doing here is we are distinguishing between equality and congruency. If their measures are the same, then the angles are congruent. And if we look, we're trying to prove that angle 1 and angle 3 are congruent to each other. We're not trying to prove that their measures are equal to each other. We're trying to prove that they are congruent to each other. So look at me when you're done writing, because I want to go back to the picture, and I'm just going to kind of talk my way through this. Okay. So here I am. So I'm looking at this picture, and what I'm going to see, this is how I'm going to start off. I look at angles, I know that vertical angles are created by opposite rays. I also know that opposite rays form linear pairs. Right? Opposite rays form linear angles. I know, digging way back, it was like 2-3 weeks ago. Maybe 4. We've only been in school for, 6 weeks? So this is week number 6. So I know that 1 and 2 right there, that's going to be a linear pair. I also know that 2 and 3 right here are also going to be a linear pair. So I can go, if 1 plus 2 equals 180, and 2 plus 3 equals 180, so I know that this pair right here and this pair right here are equal to each other, because they both equal 180. Again, 4 times 3 equals 12. 12 also equals 6 times 2. So I can bring these down and I can say 4 times 3 equals 6 times 2. Does anyone have a problem with that? If you do, go back and yell at your algebra teacher. Okay. So, don't really. So, if the measure of angle 1 plus the measure of angle 2 equals 180 degrees, and the measure of angle 2 plus the measure of angle 3 equals 180 degrees, then those two sets of numbers have to be equal to each other. And if they're equal to each other, 1 plus 2 equals 180, 2 plus 3 equals 180, then 1 and 3 have to equal each other. So we're done there. Pick up tomorrow. What we'll do is we'll actually break it down that same step by step, and we will go through and justify each step. But it's really important that you understand that this is what we're doing. We're solving a problem and then going back and justifying each step. Thank you, guys.